Okay. So like I said, right there where it says V for volume of pyramid, that's where you guys can write that formula that we just talked about. Base times height divided by 3. So if you don't have that on here, that's what we need to do. So now we're going to actually start doing some problems here where we're trying to find the volume of these different pyramids. Now remember, capital B stands for area of your base shape. So that would be the first thing that we need to do is figure out what shape is our base so that we can then figure out how to find the area of that and then work towards our height. Now, when you're dealing with height on the pyramid, you want to make sure that you're using the right side to do that. So on a pyramid in surface area, so in the last unit, we dealt with the slant height a little bit. Remember, slant height would be like this side here on the triangle face, coming down and making that right angle there. We used that when we were dealing with surface area because we were finding area of those triangles. Today, when we're doing volume, I'm not going to use that slant height. I need to use the vertical height that's inside of the pyramid. So when you guys grab your heights today, make sure they're coming from the internal piece of that pyramid. Don't grab it from the slanted side. We're no longer going to be using that side when we're doing these formulas. Let's take a look at number 1. What shape is your base here? A rectangle. Okay, so I'm just going to draw it out. It looks like it's a 4 by 6 rectangle. How would we find the area of that shape? 4 times 6, which is 24. So my base here, capital B, is just 24. Okay, we just talked that our volume formula looks like this. So now we can put in 24 for the capital B. What's the height of the pyramid? 8. And notice how it's on the inside. It's next to that dotted line that they have in there. That's the true height of the shape. And then we divide by 3. So go ahead and do that. And tell me what you get for your volume. 64. Good. And it's still centimeters cubed. Make sure you're labeling your answers. Okay. We've got to make sure that those all have labels on them and they all have the cubed when we're talking about volume. So be extra careful and make sure you're checking all those final answers, that you're labeling everything. Okay. Questions on that first one? Okay. So let's go on to number 2. What base shape are we working with for number 2? A triangle. Now it is this triangle here on the bottom. I'm just going to go over it in red. That is a right triangle. So I'm going to pull that out down here. What do you know about this triangle? 5, 13, 12. Because we know the 5 and we know that the hypotenuse is 13. And we've talked a lot about this is that pattern. We don't know this side, but that would be my 12. It's one of those Pythagorean triples that we've seen show up a lot. So how would I find the area of just this triangle? Because this would be my B. Good. 5 times 12 divided by 2, which is how much? 30. That's just capital B. Okay. Now my volume formula is capital B times height divided by 3. So we're going to plug 30 in for the B. What's the height of the pyramid? Good, the 10. Again, they're just giving it straight to you. It's on the inside of that shape there. Divided by 3, what do we get? 100. Is anyone out there, when you're looking at a problem like that, reducing in your head before you multiply? Could you reduce before you multiply? Could 3 go into 30? It goes into 30 how many times? 10 times. So then it would be just 10 times 10. So if you are working with these maybe mentally, you can reduce with that 3 if it works for you. You could reduce it into the base area or into the height if it goes into either one. And then you can just do a multiplication if you don't want to worry about dividing by 3. It won't always work out. You won't always be able to reduce before you multiply. But in times that you can, you're welcome to do that. All right, questions on number 2. Okay, number 3. What base are we working with here? A hexagon. So let's draw that hexagon out down here where it says base. What do you know about the hexagon?
Or is that just for trapezoids?
Nope. You are on the right track. We are going to be using that formula, right? Apothem times perimeter of our shape divided by 2. All right, do we know the apothem? No. So we'll have to do some work there. Could we find the perimeter? Yeah, because how much is a side? 6. So this side here is 6. And a hexagon has how many sides? 6 sides. So my perimeter would be 36. Okay, so now let's talk about the apothem because it's not given to us, unfortunately, here. So we do have to do a little bit of work. So I'm going to kind of zoom in just to this shape. I'm going to draw in here my center and a line straight down and straight to the corner. We're going to make that right triangle like we've done probably 20 times now. How much is that corner angle?
60.
This is 60, which means this one has to be 30. Okay, so we're dealing again with a 30, 60, 90 triangle. Hopefully you're maybe feeling a little bit more comfortable with working with the 30, 60, 90 triangle because you've had to do it a lot. How long is the short side of this triangle? 3, because it's half of a side length. So this is going to be 3. What I really need is this side because that's my apothem. What is that going to be?
3 squared.
Good, 3 square root of 3. Like I said, hopefully you're getting to the point now where you're like, I know how to work with this triangle. We've done it a lot, and a lot of those numbers work the same way. Okay, so now I can kind of shift back to my base area formula, and we can put in 3 radical 3 here. I would leave the radical 3 in your answer, okay? I wouldn't work with it for today. So take your 3 times 36 and then divide by 2. 54, and then that square root of 3 attaches. Remember, guys, that is only to find your capital B, so we're not done. That's the hardest part of the problem, though, is figuring out the area of the base shape. Now we go backwards to our original pyramid here, and my volume formula is what we need to finish off with here. So in for B, we can put in that 54 square root of 3. What's the height of the pyramid?
18.
Good, 18. And then if we divide by 3, what do we get?
124 squared.
Very good, centimeters cubed. There's your final answer. Sometimes what students will do is they'll do all the work for B and then they forget to go back to do volume. They think that that's the answer and then they move on. So make sure you're reminding yourself that's a lot of work just to find B sometimes, but you're not totally finished. But like I said before, finding the base area is probably the most work-inducing part of the problem. Everything else should be pretty straightforward at plugging things in. Now, 1, 2, and 3, all of those only gave you guys the true height. If you look at all 3 of these here, all of the heights on the interior of those pyramids were given to you. Okay? Well, we're not always going to have that situation. There's going to be times where we have to deal with a pyramid and they don't give us the height straight out. Maybe they give us something else that we need to work with to try to find the height. So that's what we're going to see here on number 4. On number 4, what shape is your base? A square. It's a 6 by 6 square. So what's the area of this square here? 36. Okay, so that's my B. Now remember, for volume, it's that base, which is 36, times the height, which I don't know necessarily right now, divided by 3. I'm not given the height on number 4. Do you guys see how there's an H on the inside there? What are they giving you? The slant height. We don't want to use slant height for volume. If this was surface area, I would be able to do what I need to do. But I don't want to use slant height here. I want to use regular height. So I need to kind of think about what's going on the inside here. There is a right triangle happening. Okay, the slant height is the 5. So this is like the hypotenuse side. What are the other 2 sides? Short and long legs. Now, H is the one that I need. They don't give me the bottom, that X, but could we find it? What is it? Ooh, not 5 divided by 3. What'd you say, Bree?
3.
3. How'd you get 3?
6 divided by 2.
Yeah, this is a full side. This is acting like a radius here. So this is going to be half of that. Because like all the way across would be 6. This is only going halfway. So this is just going to be 3. So if you take 6 divided by 2, you get 3. That's the bottom side of this triangle. So instead of an x here, we can think of that as 3. Now we could use Pythagorean's theorem to help me find this. Some of you might know what h is though, because I've talked to some of you in here more about some of those Pythagorean triples. Like the 5, 12, 13 is one that we see a lot, but this is another one. Anyone know what it is? Not 8. 4. Okay. H is going to be 4. 3, 4, 5 is another Pythagorean triple. So you could, if you see the 3, 4, 5, just like you see the 5, 12, 13, 8, 6, and 10, or 6, 8, 10, I should say, is another one that shows up a lot. You won't always have a perfect Pythagorean theorem. Sometimes you'll get decimals, and that's okay. But our height is 4, so we're going to plug that in up here for our volume formula. So what's the final answer? 48. Good, centimeters cubed. Don't forget that label. Okay, any questions on the pyramid?